Ay, I'm on vacation every single day, 'cause I love my occupation. Ay, ay, ay.
In this lesson, we're going to cover an introduction to vectors. We're going to look at sketching a vector, representing a vector in rectangular coordinates, and then also applying operations with vectors, and then finally the unit vector. So our first definition is the I and j unit vectors. Vector I is the unit vector whose direction is along the positive x-axis. Vector j is going to be the unit vector whose direction is along the positive y-axis. When we represent vectors in rectangular coordinates, we're going to use either the component form, ai plus and then b times j, or it will be in, again, this form where you have these carets, and then you'll have the a component and the b component. The real numbers a and b are called the scalar components of v. So here we have a diagram of a vector. You have this value a is how far you would move hypothetically to the right, b would be how far you move up, and then you draw the vector from the origin towards that point. And then you can see you have the arrow for that vector. The other thing that's going to happen is we have the magnitude of the vector. It's given using this formula. You might notice it looks very similar to Pythagorean theorem. So the magnitude is just the length of this vector. And so to find the magnitude, we have this notation where it's the double lines on either side of the v. It equals the square root of the a squared plus b squared. So you take this value, square it, then take the value in front of j and square it, add them together, and then take the square root of it. This example says sketch the given vector and then find its magnitude. So we have v equals negative 3i plus 4 times j. So the negative 3 tells us to move 3 to the left. So we're going to go 1, 2, 3, and then the positive 4 means we're going to move up 1, 2, 3, 4. So you're going to plot that point, and then we're going to draw a ray from the origin to that point. And so there's our vector, negative 3i plus 4j. Notice this vector, it's in this specific direction. It's going up to the left. And again, we found it by moving 3 to the left and up 4. Draw the vector, and then you stop at that point. Don't draw it past it because it has a specific length that we're about to find by finding its magnitude. So to find the magnitude, we're going to do the square root of, we're going to take the negative 3, square it, and then add the 4 squared. So now we're just going to simplify this, and that will be the length of this vector. So you get the square root of 9 plus 16, which becomes 25, and then the square root of 25 is 5. So the length of this vector is a length of 5. This next example, we're going to sketch the given vector. It's 3i minus 3j. So we're going to take this 3, and that means we're going to go right 3, and the negative 3 here for j is going to go down 3. So plot that point, and then draw the arrow that goes from the origin to that point. So here's your vector. Next, we're going to find the magnitude. So we're going to take 3 and square it, and then take negative 3 and square it. So now we're going to get 9 plus 9. That's going to make the square root of 18, and then we'll break it down. So when we simplify this, it's going to be the square root of 9, which is 3 root 2. So the magnitude of the vector is 3 root 2. So that's the length of this vector. Next, we have representing vectors in rectangular coordinates. It says vector v with initial point p sub 1 equals x1, y1, and terminal point p sub 2, which is x2, y2, is equal to the position vector. So when you have 2 points, the initial point and the terminal point of a vector, in order to find an expression in component form for the vector, you're going to do x2 minus x1 and put that in front of the I. Then you'll do y2 minus y1, that goes in front of the j, and then that will be your new vector. And then here would be a diagram of this vector in theory. So we have the change in x, and then here you can see the change in y, and again it creates that vector. This example says, let v be the vector from initial point, p sub 1 equals 3, negative 1. I'm going to label this x1, y1. And then we have the terminal point of the vector p sub 2, which is negative 2, 5, and I'll label this x2, y2. And the example says, write v in terms of I and j. So v equals, first we're going to do the change in x, so we'll start with x2 minus x1. So I got that set up, and then we're going to do the same thing for the y's. So we'll go y2 minus y1, so 5 minus and then negative 1, so be careful with that minus and negative. And then finally, we're just going to simplify this. So negative 2 and negative 3 makes negative 5i, And then 5 minus a negative 1, it's going to be a plus, so it's going to be 5 plus 1 is 6j. So here's our final vector. You can see it says v equals negative 5I plus 6j. And before I move on, I'm going to plot these points and draw the vector so we can get a quick visual. So we have our initial point, p sub 1. P sub 2 is negative 2, 5. And then we'll draw the vector starting at p sub 1 and going towards p sub 2. And here's our vector. You can see the direction. It's going up to the left, and then it has that specific length, which we didn't find the magnitude in this problem, but again, you can see the direction that the vector is going. All right, let's go ahead and do the next example. We have let v be the vector from initial point p sub 1 equals negative 1, 3. So I labeled x1, y1. And then you have to the terminal point p sub 2, which is 2, 7. And finally, let's go ahead and set this up. So we're going to do x sub 2 minus x sub 1. So we're going to write 2 minus a negative 1. And then we'll do the same thing with the y's. We're going to do 7 minus 3. So we get 3i plus 4j. And then last, I'm going to draw the vector over here. So we'll plot the first point, negative 1, 3. And then the second point is 2, 7. And then we'll draw the vector from the initial point to the terminal point. All right, so here's our vector. It's 3i plus 4j. We're moving 3 to the right and up 4, and then so that way you can see the direction of the vector. Next, we're going to do operations with vectors in terms of I and j. You have two vectors, in this case v and w. You can add them together by adding their corresponding components. So if you have two vectors, both with a component of I, if you're adding the two vectors, then you add those components. You can see that here. Or similarly, you can do the same thing with subtracting them. And then if you have the j component, you can add or subtract those as well. And then finally, we have what's called a scalar. We use the letter k in this case, but basically if you have a scalar k times v, for example, that means you're taking the value k and you're multiplying it to both the I and the j component. This example says if v equals 5i plus 4j and w equals 6i minus 9j, find each of the following vectors. First, we're going to add them together. So again, that means we're going to add the I components and we'll add the j components together. So 5i plus 6i makes 11i, and 4j plus negative 9j is going to be negative 5j. So therefore, v plus w becomes 11i minus 5j. It's really nice because it's kind of like the concept from our past of combining like terms, but in this case, we're combining the corresponding components. Let's go ahead and do v minus w. So we're going to take 5i subtract 6i, which makes negative I, and 4j minus negative 9j is going to be 4 minus a negative would be a positive, so you end up getting positive 13j. For part C, it says 6v, so 6 is the scalar, and we're going to take the value 6 and we're going to multiply it to both of the components for v. So I got that set up, and then now you can essentially think of distributing the 6. So you end up getting 30i plus 24j. This example says if v equals 7i plus 3j and w equals 4i minus 5j, find each of the following vectors. So for part A, we're going to add v plus w. So we'll go 7i plus 4i to make 11i, and then 3j plus negative 5j is going to be negative 2j. So there's our resulting vector. For part B, it says v subtract w. So we'll go 7 minus 4. So we get 3i, and then we'll do 3 minus a negative 5, which then becomes positive, so 3 plus 5 is 8j. So here's our vector, 3i plus 8j. For part C, it says negative 3v, so negative 3 is the scalar. So I have negative 3, and then I plugged in the vector for v, 7i plus 3j, and we'll multiply that scalar through. So we get negative 21i, and then minus 9j. And there's our answer. For part D, it says 4v minus 2 times w. So we have the scalar of 4 to multiply to v, and then we have a scalar of negative 2 to multiply to w, and then finally we'll combine them. So I got that set up. You have 4 times the vector for v, and then negative 2 times the vector for w. We'll distribute and then combine. Again, you can kind of think of it like combining like terms at that point. So here we have 28i plus 12j, and then over here we have negative 8i and positive 10j. And then again, we'll finish this by combining the corresponding components. So 28i minus 8i is going to be 20i, and 12j plus 10j will be 22j. So here's our final answer, 20i plus 22j. Next, we have a definition. It's called the unit vector. It's a vector with a magnitude of 1. So again, the magnitude is the length. So when we find a unit vector, we're essentially finding a vector with a length of 1. The unit vector is given by a vector divided by its magnitude. It also says that the unit vector, it has the same direction as the original vector v. This example says, find the unit vector in the same direction as the given vector, which is 5i minus 12j, and then verify that the vector has a magnitude of 1, or a length of 1. So part A, we're going to find the magnitude of v. So to do so, I have the magnitude set up with the square root, and then we're going to go a squared plus b squared. So we have 5 squared plus negative 12 squared. So we end up getting 25 plus 144. And then we'll add these together, so we get the square root of 169, which is 13. So the magnitude of this vector is going to be 13. Next, to write the unit vector, we're going to use this formula right here. So again, you take the original vector and put it on top in the numerator, and then we divide by the magnitude, which we just found to be 13. And at this point, we want to write this in component form. So we want ai plus b times j. So we're going to split this when you have two terms on top, one on the bottom. I like to call it the heart, where we take 5 divided by 13, and then you'll just write I next to that. And then we take negative 12 divided by 13. So here's our unit vector. It's 5 over 13i minus 12 over 13j. Part C says verify that this vector has a magnitude of 1. So I have a big square root, and we're going to take this value for a, square it, and then add it to this value for b squared. Okay, let's go ahead and simplify this. So 5 over 13 squared, it's going to be 5 squared divided by 13 squared. So you end up getting 25 again over 169, and then we're going to add, and we'll do the same thing to this fraction. Negative 12 squared is going to be 144, and that's divided by 13 squared. And then we'll add this to be one fraction. So you do 25 plus 144, which also makes 169, and this will simplify to be the square root of 1, which is 1. So we found the magnitude of this vector, and we got a length of 1. This example says, find the unit vector in the same direction as the vector v equals 4i minus 3j, then verify that the vector has magnitude 1. So step 1, we're going to find the magnitude. So we're going to take 4, square it, and then add negative 3 squared. And then let's go ahead and simplify this. 16 plus 9 is 25, and the square root of 25 is 5. Step 2 is going to be set up the unit vector. So we take the original vector v and we divide by the magnitude we just found. So I have it set up. We have vector v divided by the magnitude of 5, and then we're going to rewrite this in component form. So you get 4 over 5i, and then we're going to go negative 3 over 5j, and here's our unit vector, 4/5 I minus 3/5 j. The very last step, we're going to verify that the vector has magnitude 1. So we're going to find the magnitude of this vector. We're going to take 4/5 square it plus negative 3/5 squared. So 4 over 5 squared is going to be 16 over 25, and negative 3 squared is 9 over 25. So finally, we'll add these fractions. 16 plus 9 is 25 over 25. So you get square root of 1, which equals 1. So we just verified that this unit vector does in fact have a length of 1. All right, guys, thanks for watching and have a great day.
Hey, I'm on vacation. If you don't like your life, then you should go and change it. Hey, I'm on vacation. Every single